In this video, we are going to see where do we find square roots in real life and what are the practical applications of square roots. So suppose if somebody asks you, why is this button on the calculator? Have you ever used it? Or you ask yourself, am I ever going to use square roots in real life? So I have a suggestion for you. Let us rephrase the same question. Let us ask, are square roots really useful in real life? I do not use it, but does anyone use square roots in real life? Or can I too make some meaningful use of square roots? And the answer to this is yes, we can. So what are square roots? If I say 6 squared is 6 multiplied by 6, means we are using the 6 two times, we get the answer as 6 is 36. So the opposite of it, the reverse of it is the square root of 36 is 6. Similarly, if I say 10 squared is 10 tens are 100. So that means that the square root of 100 is 10. Why? Because 10 tens is 100. But there are many numbers who do not have a perfect square root. For instance, square root of 8 does not have any perfect integer answer. So its approximate answer is 2.828. Such numbers are called irrational numbers. So we can of course add or subtract or multiply or divide using a calculator. But remember, adding, subtracting, multiplying and dividing can also be done without the help of a calculator, and that too easily. But if you really wanted to find the square root without a calculator, you would have to do this. This is the division method of finding the square roots. So calculator really comes very handy. So that square root button on the calculator is very useful button. Suppose if we want to find the area of a triangle whose sides are A, B and C, which means this length is represented by small a, this length is represented by small b, and this length is represented by small c. There is a Heron's formula to find the area of the triangle, which goes as follows. Area of the triangle is equal to the square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, where S means the semi-perimeter or the total of all the three sides, A plus B plus C, the whole upon 2. So it is like perimeter of the triangle upon 2, half perimeter, semi-perimeter. So once you find the semi-perimeter, substitute in this formula. Remember, it also has a square root in it, which is the topic of the day, and you can find the area of the triangle. For example, if the three sides of the triangle are 11, 16 and 17, small a is 11, small b is 16, small c is 17, and the semi-perimeter would be 44.2, which is 22. So if we substitute in the area of the triangle's formula, it is 22 into 22 minus 11 into 22 minus 16 into 22 minus 17, which turns out to be the square root of 7260. Of course, we can do it by square root by division method or simply using a calculator, and it would be approximately equal to 85.206 square units. So you'll be telling me, why am I showing all these things? Just wait a minute. Suppose if you wanted to buy an air conditioner and you've been told that if your room's area is less than 120 square feet, you need to buy a 1.2 ton air conditioner. And if your room's area is between 120 square feet and 180 square feet, then 1.5 ton will do. But if your area of the room is more than 180 square feet, you require a 2 ton or maybe even more, bigger air conditioner. And the area of the room turns out to be a perfect a rectangle, the shape is a rectangle. So whose length is 17.3 feet and the breadth is 11 feet. So we know how to find the areas of rectangle. The area of rectangle is length multiplied by breadth, which is 17.3 multiplied by 11, which is 190.3 square feet. So it turns out that since it is more than 180 square feet, a 2-ton air conditioner is required. So it is useful, finding areas is useful to make such decisions. But what if the room that you are seeking for is not a perfect rectangle? It is a quadrilateral like this, ABCD, whose 4 sides are given, but you do not know how to find the area of this particular quadrilateral. So now what can we do? We can convert this quadrilateral into 2 triangles, either by joining AC and measuring it, or BD and measuring it. Suppose if you join BD and if you measure it to be 16 feet, you can measure this with the help of a measuring tape or a meter scale. Then now we have 2 triangles. One is triangle ABD and other is triangle BCD. So for triangle ABD, the 3 sides are 11, 14 and 16. We find the semi-perimeter to be 20.5. And then we substitute in the formula for the area, and it turns out to be approximately 75.475. We did the same thing. We took this semi-perimeter and then we use this formula, square root of s into s minus a into s minus b into s minus c, where a is 11, b is 14 and c is 16. And in the same manner, we can take this triangle BCD and find semi-perimeter and then substitute in the formula of the area to get the area to be approximately 58.723. Now what? We can add the two areas to get 134.198. So we need to buy a 1.5-ton AC. So you can see that by dividing a quadrilateral of any shape, by joining the diagonal, any diagonal, we have divided into 2 triangles, and Heron's formula makes it easy to find the area of a triangle. Or if you are wishing to buy a piece of land in your village or somewhere else, and you know the boundaries of that particular piece of land, it is very difficult for you to find the area of this. But you can divide this piece of land into small triangles, either by joining BD or AC or AE, AF and so on. So you can divide this piece of land into many small triangles like this, and you should be able to measure that length of the side of that triangle. So it turns out to be 10.77, 7.08 meters, etc. And now we can find the areas of all these triangles one by one, because now we have all the 3 sides of each and every triangle. So by using the Heron's formula, we can come to know the area of this triangle is about 19, the area of this triangle is about 15.5, this is 21, this is 12, and that is 7.1. And if you total up, you get the area of this entire diagram, 75.051. So finding the area of triangle is of a very prime importance. And to find the area of triangle, you always require that square root button. You all must be knowing by now what is Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is the sum of the squares of the other 2 sides. That is, c squared is equal to a squared plus b squared. If I take the square on the other side, or if I square root both sides, I'll be getting c is equal to square root of a square plus b square. So suppose if we have a triangle whose sides making the right angle are 5 and 6, the hypotenuse c would be the square root of 5 square plus 6 square, which is 25, square root of 25 plus 36, which is square root of 61, which is approximately 7.8102. Now, you may be asking that, of course, we can make such a triangle and we can directly measure the length of that triangle. Of course, we can do that. And when you measure that length of the triangle, you must be getting around 7.8, whatever, centimeter or meter. But the actual length is not 7.8, it is a little more than 7.8. And secondly, maths makes it very, very easy that we can find the length of this side or any other side even without constructing any triangle. So we should be having that particular tool or that particular part to find the length of the side or the angle even without actually drawing one. And this is super useful. Suppose you want to buy a television set which is of 32 inch and the aspect ratio or the dimensions of it is in the ratio 16:9. So you wanted to know what is the length of this particular TV screen wise and what is the breadth of this TV screen wise. Now always remember, when we are being told that the TV is 32-inch TV, it means that the diagonal is 32 inch and not the length or the breadth. Of course, this diagonal will also be 32 inch. And since the ratio is 16:9, we can say that let the common multiple be x, and the A or the length portion will be then 16x, and B, which is the breadth portion, will be 9x. So we know that c square is equal to a square plus b square, which is Pythagoras theorem. But this time we know the hypotenuse is 32. So 32 square is 16x the whole square plus 9x the whole square, which means 1024 is 256x square plus 81x square. So 1024 is 337x square. Therefore, x square is 1024 upon 337, which means that x is equal to square root of 1024 upon 337, which is about 1.743. So we substitute, we get a is equal to 16x, which is approximately equal to 16 multiplied by 1.743, which is 27.888 or almost 27.9. And similarly, the breadth of this TV would be 9x, which would be about 15.7. So even without buying and even without measuring that television, we could come to know what is the length and the breadth of that television. And if we extend this Pythagoras theorem, and if we want to find the length of the longest particular chord or the diagonal of a cuboid having length small l, breadth small b, and height small h, the length of that longest diagonal is square root of l square plus b square plus h square. So suppose if you want to know what is the length of the biggest possible pencil that you can fit in this compass box, whose length is 15 centimeter, breadth is 5 centimeter, and the height is 3 centimeter, you can just substitute in this formula. So the longest pencil would be square root of 15 square plus 5 square plus 3 square, which is square root of 225 plus 25 plus 9, which is square root of 259, which is about 16.09. So we can say that the longest pencil that can be fitted in this compass box would be 16 centimeter. Now, in real life, when we make constructions, what do? We take that piece of land and we draw a map of it. And then we fix any particular point as an origin. So it could be this particular point as the origin, or this point, or this point, or any other point. And then we draw the x and the y-axis. And then we fix each and every point and we find the coordinates of that point. Something like this. So over here, let us say this particular point of the diagram was fixed as the origin. And this point and this point would be having the coordinates. For example, this point A has coordinates 5, 1, and this point B would then have the coordinates -2, 5. Then we can come to know what is the distance between these 2 points, of course, on the map and then on the real ground by using coordinate geometry. So we can say that this point has the coordinates 5, 1, and B has the coordinates -2, 5. And by using the distance formula, which is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We substitute the numbers minus 2 minus 5 the whole square plus 5 minus 1 the whole square, which is square root of minus 7 square plus 4 square, which is square root of 49 plus 16, which is square root of 65, which is about 8.062. So the distance between these 2 points, either on the map or the ground, depending upon the units we use, is 8.062. So we can also find the distance between any other points if we come to know the coordinates of those points. And as you see, we have used square roots in all these things. Similarly, we can find the distance between any 2 points in a 3 coordinate system. For example, the point A is minus 1, 3, 3 and B is 4, minus 2, minus 2. We can extend that particular distance formula and we can find the distance between them. So the distance between them would be square root of the differences of the x squared plus differences of the y squared plus differences of the z squared. And then we substitute in the numbers to get the answer as square root of 75, which is 8.660. Remember, all these distance formulas have square roots in it. But there is another way we can use or consider this formula to be. Now, suppose if I tell you or ask you, can you tell me what colors are these? The boys would say, this is green, this is green, this is green, and this is also green. And the girls would say, this is sea green, this is apple green, this is dark green, this is bright green. Wow. So there are so many different types of green also. But one thing that we can understand is that this dark green and bright green are totally different types of green. And this is also a sort of dark green, but not exactly dark. So using maths and using the same distance formula, we can actually quantify all these differences of colors. So if you take a color picker and if you pick these colors, you would come to know that sea green has the red, green, blue ratios 46, 139, 87. Not the ratio, but the coordinates. And the coordinates of this on the RGB scale is 141, 182, and 0. Dark green is 150 and 32. And bright green is 102, 255, and 0. So in RGB, the numbers could be a minimum of 0 and a maximum of 255. So this is a minimum 0, this is maximum 255. So the color black is represented as 000 and the white color is represented as 255, 255, 255. Now you can consider this to be x1, y1, z1, this to be x2, y2, z2, and you can use the same distance formula that we saw on the previous slide and substitute in the numbers. So 46 minus 141 the whole square, 139 minus 182 the whole square, 87 minus 0 the whole square, which we get this. And then on further simplifying and approximating it, we come to know that the distance between these two colors is 136. Similarly, we can find the other distances. The distance between these two colors is 231, which is more than 136. And the distance between these two colors is 114. And the distance between these two colors is 83. So they are very close to each other. Distance between these two colors is 155. And distance between these two colors is 195. So we can actually quantify the distances or the differences of the colors. Remember, the minimum distance would be 0 if they are the same colors, and the maximum distance would be, of course, between the black and the white, would be about 442. So another way of thinking the coordinate system is to find the distance between the colors. Now, let us look at another example where we can use square roots. Suppose if we have 3 players, A, B, and C, and in the last 5 games, A has scored 46 runs, 57 runs, 68 runs, 78 runs, and 33 runs, while B has scored 115 runs, 22, 97, 0, and 53, while C has only played 4 games and has scored 93, 28, 41, 60. And you want to decide who you should select for the next game. You have only one slot, and remember they always lost their wickets whenever they played. So the total comes up to 282, 287, and 222, while the averages is 56.4, 57.4, and 55.5. Now, looking at the average, you would say that, of course, this player B is a better player than, of course, A, and then A is better than C. But would you really like to choose B instead of A or instead of C? So, how do we decide that? Of course, their averages are not very much far away from each other. To help us in this particular thing, we take the use of standard deviation. Standard deviation is given by this formula. Sigma, or the standard deviation, is the square root of the summation of the square of the differences of the individual numbers from their mean, the whole upon n. Oh my goodness, what does this mean? This means that, let us take the player A. He scored 46, 57, 68, 78, 33 runs with a total of 282 and average of 56.4. So how did we find the average? By dividing this total by 5. So first of all, we are going to take these individual numbers and subtract it from the average. Remember, this mu is the average, 56.4. So 46 minus 56.4, which I've written over here, and whose answer is minus 10.4. And then 57 minus the average 56.4 is 0.6, and so on. So we come to know that on an average, in this particular match, he scored 10.4 runs less. In this particular second match, he scored almost the average number of runs. And over here, he scored more than the average, 11 runs more or 12 runs more. Over here, he scored nearly 22 runs more. And in this match, he scored almost 23 runs less than the average. But these signs, either negative or positive, can be removed by squaring them. So we square them. So this square actually means that. And the answer to this is over here. So we square the 0.6 to get 0.36 and so on. And then we total up all these red numbers. So the summation means the total of the squares to get 1257.2. Now, when we divide it by n, which is 5 in this case, because there are 5 matches, we get an average of 251.44. And finally, we take the square root to get 15.86. So this final answer, which is a square root, is called the standard deviation. Means on an average, this player scores either 15.86 more than the average or 15.86 less than the average, and thus he does mostly 60-70% of the times. So in the same way, we can find the standard deviations of B and that of C. You can see the standard deviation of A is the least, 15.86, while that of B is 43.4 and C is 24.4, which means that though the player A has an average of 56.4, which is slightly less than 57.4, he is more reliable, means he scores more runs closer to his average, while this player B does not score runs closer to his average. He either scores a 0 or scores a century. He either scores a 22 or scores a run very close to the century. So this player is not that consistent. And similarly, the standard deviation of C is 24.4. So lesser the standard deviation, more is the consistency. And more is the consistency means more the player is reliable. So it would be better that if we select A rather than B or C. Similarly, square roots are also used in other statistical measurements like correlation, regression, and many other things. Square roots are frequently used in physics. For example, take this formula. T is equal to or approximately equal to 2 pi the square root of the length of the pendulum upon the g, which is the local strength of gravity. So if you want to know how much time does the pendulum take for one complete oscillation, we can use this particular formula. Similarly, we can also find the value of g if we know t and we know L. So a pendulum can therefore be used as a gravimeter to measure the local gravity. But you can see square roots are used in physics very often. You all must be knowing about the A4 size paper, which we mostly use to take the printouts. But do we know that if you double the A4 size paper, you get the A3 size paper? And if you double it, you get the A2. If you double it, you get the A1. And if you double it, you get the A0. So in other words, this entire paper is the A0 paper. And if you fold this A0 paper lengthwise into two equal halves, means the length gets divided into half of the length, we get the A1 size paper. Similarly, this is the length of the A1 size paper, this is the breadth, and if you divide the A1 size paper lengthwise into two equal halves, you get the A2 size paper. So it can be seen that this length of the A0 size paper L upon this breadth of the A0 size paper, which is B, would be in the same ratio as that of the A1 size paper, whose length would be the breadth of the A0 size paper and whose breadth would be half the length of the A0 size paper. The ratio does not change. So the ratio of even the A4 size paper or the A5 size paper is always the same. If you cross multiply, you get L square is equal to 2 times B square. Or in other words, L square upon B square is 2. If you take the square root of both sides, you get the length upon breadth is exactly equal to the square root of 2. You see, again you see a square root, which is approximately equal to 1.4142. This is an irrational number. But when we are really making these A4 size papers, we require a proper measurement nearest to the closest to the nearest millimeter. So we cannot use this irrational number, of course. So for the A4 size paper, we use 297 millimeters as length, while 210 millimeters as breadth. And if you divide this, you'll get almost the square root of 2. So next time you see an A4 size paper, if you divide the length and the breadth, you almost get a square root of 2. Square roots also exist wherever the squares exist. For example, if I say area of the square is side square, it means the side is equal to square root of the area. Similarly, area of the circle is pi r square, E is equal to mc square, h is equal to half gt square. All these are physics formulae, and in all the formulae, we can see that there are squares. So you can find many such formulae, and I hope you understood this. And if you really like this video, please share. And if you have not subscribed to my channel, please subscribe to it. And thanks for watching.